Support Moof University in the production of more video tutorials by making a financial contribution or by getting yourself one of these t-shirts. Details under the Support Moof section on moofuniversity.com. The link will be in the description below. Thank you and enjoy.
No video series on the basics of chemistry is complete without at least mentioning the periodic table of elements. So before we get into it, I have 3 questions that I want to sort of ask and get out of the way before we start talking about it. The first one is, what is an element, right? We're talking about the periodic table of elements. What is an element? An element simply is a substance that cannot be broken down any further. Now that is a simple definition. We'll talk more about it in the next video. But for now, that can kind of be it. I'll mention also that an element is made up specifically of only one atom. But we'll talk more about that later. Basically, an element is the simplest type of matter, okay? Which is why we have this table to help us keep track of the different simplest forms of matter, right? How many elements are there? Currently, as of July 2015, there are 118 known elements, and approximately 90 of them occur naturally, which means that some of these were discovered in labs with chemists sort of doing their thing. Okay, so another question is, who came up with this thing? Genius dude. Russian chemist Dmitry Mendeleev, like that. I think I spelled that correctly. So what he did was, he's pretty brilliant. What he did was, at the time there were a certain number of known elements, and what he did was he arranged the elements that they were known at the time by relative masses. Or specifically what we know now, or what we call the atomic mass. And he grouped them according to their reactivity or their properties. Okay. And what he did was, when he put this all together, and at least initially, when he arranged them by these masses and put them in certain groups, of elements that reacted similarly, what he did was he found holes or gaps in the table where an element was oops, I wrote table there. Gaps or holes in the table, where he thought, okay, there's a missing element here. But what he did was he made predictions about that element, that little unknown element, and about their properties. So the hope was that when they were discovered, that they would have the properties that he predicted, and that actually turned out to be the case. I think at the time there were 2 elements, gallium and germanium, numbers 31 and 32 here, and I'll get to what those numbers mean in just a second. They weren't there, but he did know about aluminum and silicon, and he thought, gallium should be similar to aluminum, and germanium should be similar to silicon. He guessed certain different things. I won't get into all the details about what he specifically guessed, but the point is that they were discovered, and a lot of his predictions were pretty much right, which is crazy. That's pretty genius if you think about it. Okay, so basically he gave rise to what is now the modern day periodic table, which is shown here, and we'll talk a little bit about it and kind of how to look at it, and sort of so we can understand what's going on here. What Mendeleev initially did was he arranged them by relative masses. Now the periodic table is arranged by atomic number, which is the number of protons an element has. So each one of these little squares, or they're kind of like rectangles, but each of these little blocks represents a particular element. And we got this little key here to the right. The number on top is the atomic number. That's actually the number of protons. We'll talk more about that in the video about atoms. The letter or letters is the atomic symbol. And often what is the case actually is that the letter is the first letter of the name of the element, or the first 2 letters, or at least 2 letters of the name. Sometimes it's in English, sometimes it's in Latin. Latin, for instance. The H is hydrogen, so I'll write that down over here to the left. So the H is hydrogen. He is helium. So those are in English, but Na is sodium. So that's kind of weird, right? But it's actually named for, or the symbol is from natrium, which is sodium in Latin. Okay. This W down here, number 74, that's tungsten, right? Tungsten, but that comes from the German wolfram. And if my pronunciations of those are wrong in any way to people who speak those languages, I apologize. Anyway, but most often though, it's the first letter or first two letters of that element, or at least two letters in that element's name. And that last number at the bottom is the average atomic mass, which is basically the if you add up all the different isotopes masses and divide based on the relative abundance of those. That doesn't make sense to you quite yet, but it will later. Okay, unless you already know this stuff. Anyway, another thing that you'll notice is a lot of these symbols are written in black. If they're written in black, that means that thing is a solid at the temperature of 0 degrees Celsius or 32 degrees Fahrenheit, 273 Kelvin. Okay. If it's written in red, like hydrogen or helium up here, it's a gas at that temperature. If it's written in white, like bromine over here, number 35, and mercury, Hg, number 80 here, those are liquids at that temperature. And if it's gray, it's unknown. That's basically because those elements, for whatever reason, or excuse me, not for whatever reason, those elements are not stable enough to really figure it out. In fact, some of them have their masses written in parentheses. The parentheses denote that the mass of either the most stable isotope or the isotope with the longest half-life. Okay. Some of these don't actually make sense, but don't worry about that. At a certain point, you'll be able to refer back to this periodic table and make sense of what I'm saying. Okay. Now, something that's pretty crucial to understand is that there are rows and columns, which is probably pretty obvious from. But what's important to note is that the rows, right, going left to right, are called periods. That's why it's called the periodic table. Okay. So there are how many rows? There are 1, 2, 3, 4, 5, 6, 7. You might think 8, 9, but that's not the case. That's because these two rows are actually supposed to fit right in here. You'll notice in the color coding, 57 to 71 kind of belong here. 89 to 103 kind of belong here. So there are 7 rows in the periodic table, 7 periods. Okay. And then there are columns, right? There are 18 columns that are shown here. 18 columns. The columns are called groups. Okay. So we mentioned before that Mendeleev sort of grouped things according to their reactivity and properties. That's still the case here. These things that are in columns, the elements that are in the same column have similar reactivity and properties. Okay, that's actually really, really crucial to remember. Similar reactivity and properties. Try to fit that in there. Okay. In fact, a lot of them have, a lot of the groups are specifically given particular names, so that we can remember them by. So you can see here that there are 18 columns, 1 through 18, going left to right, right? The columns, of course, are up and down. So this orange column, yellow column, there's these 2 blue columns at the end. But you'll notice that there are some that are numbered 1A, 2A, and then 3 through 8A over here, the first 2 columns and the last 6 columns. Those are called the main group elements. And part of that is just because they just show up kind of often in chemistry. Okay. So let's scroll this down just a tad bit more. Okay. So how many columns or groups are there? Well, I just said 18, so we could say that, right? 18 groups. But what you can do is, because these guys, these last 2, this purple and red row down here at the bottom, they're kind of taken out of the table and put below it. They can be considered their own columns, right? These 14, if you count from left to right, there's 14 columns there. And you can think about them as being different groups because of their electron configurations, which might not make sense to you quite yet, because we haven't covered electron configurations. But you could look at this as 14 groups in addition to the 18 up here. So you could think, some people, depending on who you ask, you might see some people say 18 columns or 18 groups versus 32. Okay, because then of course this 32 is just coming from the 18 that are up here plus the 14 down here, right, which would be 32. Excuse me, 32 columns or 32 groups. Okay, so what are the names of some of these groups, and what are some tidbits of knowledge that we should or might want to be familiar with? This first group here, group 1A, excluding hydrogen. Actually, before I even mention that, there's this dark block here, this dark sort of staircase right here, little border here. This little border separates the left side of the table from the right side. Basically, things to the left, generally speaking, are metals, and things to the right are nonmetals. Okay. Now, that's the general. This is generally speaking, right? Within that, there are specific names for specific groups. Okay. And that's what we'll go over now. So this first group, group 1A, excluding hydrogen, it's called the alkali metals. The alkali metals. So they are soft, silvery metals that are particularly violently reactive with water, and they can cause little tiny explosions. Like if you put lithium, a small piece of lithium in water, it can spark a little bit, little mini explosion. If you put rubidium or cesium, it can cause a much larger explosion. I don't recommend that you do that, just to be clear. Also, they're called alkali because if they react with water, they can give basic products. Okay. The group right next to them, 2A, group 2A, is the alkaline earth metals. Okay, and they also react with water to give basic products, hence the alkaline name. And they do react somewhat violently with water, but not nearly as violently as the group 1A elements. Okay. The purple group here in the middle, or excuse me, not purple, this light sort of pink group here, faint pink, those are the transition metals. There's a bunch to say about them, but I won't really talk about it right now. This is just an intro video, and I think it's pretty long already. But that little block there is called the transition metals. And the next group here, the sort of like tannish gray here, they're called the post-transition metals, and sometimes they're called the main group metals, I've seen, because they're metals that are part of this main group, right? 1A, 2A, all the way to 8A, right? Between 3 and 8A. So since they're in that main group element block, sometimes they're called main group metals. Okay. This sort of dark green here, along this sort of staircase, these elements are called the semimetals or metalloids. Okay. And the reason why is because they're kind of at that border between the metals and the nonmetals, and these elements can sometimes have traits of metals and some traits of nonmetals. Of course, now the things to the right of that are the nonmetals. Things in the green are nonmetals. And these next two groups, 7A and 8A, are also nonmetals, but they have specific names. Group 7A is called the halogens, and they're called that because hal comes from the Greek word meaning salt, and they're involved in a lot of salts. In fact, you might have heard of table salt being sodium chloride, so I'll write that down here, sodium chloride, NaCl. A lot of the times the alkali metals or the alkaline earth metals would be interacting with one of the halogens to make salt. In fact, NaCl is table salt. Sodium chloride is table salt. Right, so that's an alkali metal with a halogen. Okay. This last column over here at the very end, 8A, these are the noble gases, sometimes called the inert gases because they're not very reactive. Okay, and I'll actually write that word to the side there, inert gases. The last two down here, these are called the inner transition metals, inner transition elements. or inner transition metals. And they are called the row here, starting with La, called the lanthanides, and the group right under it, starting with AC, are called the actinides. Okay, together they are the inner transition metals. Okay. Now, generally speaking, when it comes to metals, they are solid, shiny, malleable. Malleable basically means that you can kind of alter their form. You can like bend and change the shape of metals. And that doesn't mean it's easy, but you've probably seen like people like melt down weapons and stuff like that, or change the form of weapons, or like bend an iron bar or something like that. Ductile basically means that you can form it into wire. So like you guys might know with copper wire, copper is Cu right here, number 29. Metals are also good conductors of heat and electricity, so they allow heat and electricity to flow very well. That's especially important when we're talking about ductile, because electricity, right? We need electricity flows. We know it flows through wires, right? So that should make sense a little bit there. Nonmetals, most of them are gases, of course at this temperature. Bromine is a liquid. Carbon, phosphorus, sulfur, selenium, and iodine are all solid. They can be pretty colorful. They can be brittle if they are solid, and they're poor conductors of heat and electricity. Semi-metals kind of have the traits of both, right? They're shiny like metals are, but they can be brittle like non-metals are, and they're semiconductors. They're sort of not really good conductors and not very good insulators, so they're kind of somewhere in between. And yeah, that's about it. I hope that video was helpful as an intro to the periodic table of elements. Thank you for watching.
If you found that video helpful, be sure to hit it with a like, and don't forget to subscribe if you haven't already. Also, be sure to share the video with anyone who you think might find it helpful. Thanks, and happy studying.